Hello, so today these are our goals for this video in no particular order because we're going to skip around a little bit. So the first thing I really want you guys to understand is that roots and zeros and x-intercepts are all the exact same thing, okay? And we use them interchangeably, unfortunately. So roots are the same as zeros, are the same as x-intercepts. Okay, and all these are, they tell us when the polynomial crosses the x-axis. Okay, also meaning this is when y equals 0. So your point is actually going to look like, it's always going to be a number, whatever your x value is, and a 0. Okay, so how do you find zeros or roots given a polynomial? Okay, so the first thing that you're going to do is, let's say they give us the standard form, x squared minus x plus 6, right? Okay, so the first thing you're going to do is find out what are factors of 6 that add to -1. And I always say it's always what are factors of c that add to b, okay? So factors of c that add to b, okay? So right here, we know the difference is gonna be 1, so we know it's gonna be 3 and 2. Now, which of these is gonna give us a result of -1? That's gonna be on the 3. Oh, guys, I'm so sorry. This was supposed to be a -6. So what are factors of -6 that add to -1? -3 and +2. So sorry. Whenever you see this from here on out in the video, this is supposed to be -6, not positive. Ugh. So here are factors are x minus 3 and x plus 2. Okay, those are the factors. Now we have to take the factors, set them equal to 0 to find the roots. So x minus 3 equals 0, x plus 2 equals 0. So our roots are 3 and -2. So here we have standard form and here we have factored form, okay? Now let's talk about in behavior. The first thing you're going to look at is the lead coefficient, okay? If it's positive, your right side ends up. If it's negative, the right side ends down, okay? The next thing you're going to look at is the lead power, meaning the highest power. Okay, oh, and one thing, the lead coefficient is always with the variable that has the highest power, your lead power, okay? If it is even, the left side follows the right side. And if it's odd, you guessed it, left side is opposite the right side. Okay, so as an example, let's say -2x to the 4th plus 3x cubed, so on and so forth, because really all we're looking at is this first lead coefficient, lead power. Okay, so our lead coefficient is negative, so right side ends down. Our lead power is 4, which is even, so it follows the right. Okay, so now how we're going to write this, as x goes to -infinity, f of x goes to, right, it goes down, so -infinity as well. So as x goes to -infinity, y goes to -infinity. Okay, and as x goes to +infinity, right, this way, y goes down. So f of x goes to -infinity as well. All right, let's do one more example. Let's do positive 4x cubed plus blah, 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 blah. All right. So first thing we look at is our lead coefficient. It is positive, so right side ends up. Our lead power is 3, so it's odd. So left side is opposite, so it ends down. So as x goes to negative infinity, f of x goes to, right, goes down, so negative infinity. As x goes to positive infinity, f of x goes, all right, so it's odd, so it goes up, so it goes to positive infinity. That's all for end behavior. All right, now let's look at multiplicity. All this means is the number of times the root, or really what we're going to look at is the factor, occurs. And to do this, you look at the power on the factor. Okay, now why do we look at this? All right, so if the power on the factor is odd, okay, the graph goes through that root. Okay, if it's even, the graph will bounce at that root. Sorry, I just realized I was writing very free-handed. Okay, so what does that mean for us? What are we going to use it for? Okay, so let's say we have a polynomial in factored form that says 10x minus 3, x plus 5 squared, x minus 4 cubed. All right, so the first thing we're going to look at is our zeros. Okay, so here are our factors. Our 0 here is 3, 0 here is negative 5, 0 here is positive 4. Okay, now what we're going to do is look and see what the graph is going to do at those roots. So at x equals 3, the multiplicity is 1, so it goes through. Okay, at x equals negative 5, the multiplicity is 2. It's even, so it's going to bounce. Okay, at x equals 4, multiplicity is 3, which is odd, so it goes through. Okay, now we'll do a rough sketch of what our graph is going to look like. Okay, so we know we're going to have, okay, at x equals 3, 1, 2, 3. Okay, x equals negative 5, and x equals positive 4. All right, now let's look at end behavior. Okay, the lead coefficient is going to be 10. Okay, if you had other numbers in here, just multiply them through in your head so you can find out if the lead coefficient, and you're just looking at positive and negative, okay? So like let's say if this was negative, right? This lead coefficient would be negative 10, okay? So just multiply all the numbers, the lead coefficients out, and look for positive or negative. Okay, so here it's going to be positive because the 10 is positive and these x's are positive, okay? So we know that the right side is going to end up. Okay, now we look for the lead power. So we have x to the first, x squared, and x cubed. So we have 1, 2, 3, 4, 5, 6. Okay, so our lead power is even, which means the left side is going to follow the right side. Awesome. Okay, so now negative 5, it's going to bounce. Okay, then somewhere over here, it's going to have a max, but then it's going to go through and go through. Okay, so again, very rough sketch. Okay. Okay, So that's all we need, all we can get from looking at multiplicity and end behavior, but at least it gives us a really good rough sketch of what we're dealing with, okay? This is especially important when you're dealing with problems where you're not allowed to use a calculator. All right. So while we're here, let's look at the positivity and negativity of our graph, okay? So positive, negative of the graph. Okay, so all we're looking at is when is the graph above or below the x-axis. Okay, so really what we're looking at is the y values. Okay, when are they positive? When are they negative across our domain? All right, so let's look at this. Okay, here it's above the x-axis. Again, this is all above the x-axis, and this is above the x-axis. So the only time that our graph is below the x-axis is in between these two roots, okay? Okay, now, so how do we write this? Okay, so f of x is positive or above the x-axis for the x values of, okay, so it goes from negative infinity, right? And when does it turn red? Here, 1, 2, 3, positive 3. Union, because it goes back up again at our root of 4. And then it's going to stay positive, so positive infinity. Okay, f of x is negative, right? Only between these two roots. So positive 3 to positive 4. Okay, also while we're here, let's talk about story problems. Oh. Now, the story problems I'm talking about are when they give you a big polynomial, okay? And they're gonna ask you a question like, when does the store turn a profit? At what time does the apple hit the ground? You know, something like that. So you're going to start thinking of these roots as either time or, well, definitely time goes along the domain 90, well, I would say 100% of the time. I've never seen time on a y-axis, but it's always like time to do something, like basketball to hit the hoop, whatever have you, okay? But what I want you to keep in mind is you're just looking for zeros, okay? Read the question and then try to interpret that into the zeros, okay? So the biggest thing to do in order to get the right answer for these is just to graph it on your calculator, look at the zeros, and then look at the options that they give you, and then you'll be able to realize which answer is correct, okay? So like say this one is looking at something where they want to know when a deficit happens, okay? So we see that we have a deficit, i.e. the y value is negative, okay? We have a deficit between 3 and 4 here, okay? So that your answer could be, okay, this deficit or something is not there between markers 3 and 4. And that's it. Okay, so last thing, let's talk about how to find the polynomial when you're actually given the zeros, okay? So first things first, like let's even look over here first, right? So if we're given these zeros, okay, we're actually going to work backwards to find the polynomial, okay? So the first thing you do is move the number over to be with the x, right? So we're going to subtract the 3 over, we're going to add the 2 over. Okay, now at this point, we have factors. So the factors are then going to get multiplied together, and then you're going to FOIL to get the polynomial back in standard form. That's all you do here, okay? We're just working backwards. So your steps are first, change the roots to factors. Okay, so add or subtract over. And then number 2, if they're asking for standard form, FOIL out. All right, now we did a simple one going backwards over here, but if we have a special case of either square root or an imaginary number. Okay, so if they're asking you to actually count the number of roots, okay, you have to count these as 2, because in order to get a square root or an imaginary number, you have just square rooted both sides, right? So whenever you square root both sides, you get a positive and a negative. So let's say the question is you have roots at 2, 3, and root 5, okay? Technically looking at it, you only have 3, but remember, you have a positive and a negative root 5. So your total number of roots is actually 1, 2, 3, and 4, okay? Same thing with imaginary numbers. Let's say we had 6, 7, and 3i, negative 3i, okay? They may trick you on that. So again, it looks like 1, 2, 3, but remember you have an imaginary number here. So if you have a negative, you have a positive, because imaginary number, the I represents the square root of -1. So you're going to have 1 and 2 of those. So again, 1, 2, 3, 4. Number of roots, 4. Okay, now how to work backwards if you're given a root or an imaginary number. Okay, so let's do an example. Let's say we have roots at 3 and 2i. Okay, first thing you do is set up your roots. Okay, now make them factors. Subtract the 3 over. Done, we have our factor. This one's gonna be a little more complicated because we can't just move this over, okay? The first thing we have to do is square both sides to get rid of the square root -1. Okay, so x squared equals 2 squared 4i squared. And remember, I squared is actually -1. So x squared is equal to -4. Now we can move it over. Okay, now that they both equal 0, we have our factors. And then if they want standard form, just FOIL it out. Right? What does that look like with root? Let's say we have x equals 0. Throw that one in. Forgot about that one. X equals 0. And x equals, let's just say square root 2. Negative square root 2. Okay? So the first thing we do is set our factors up, or our roots up. Okay? This one's already equal to 0, so it's done. We have our factor. This one, we're going to have to square it first to get rid of that root. So x squared, negative squared is a positive. Square root squared gets rid of it, and we're just left with 2. Now subtract it over. Okay, they both equal 0. Now what is our polynomial? X times x squared minus 2. And again, if they want it in standard form, just distribute that x through.